My name is Dan Milliron. I am one of the local SEs here. I cover one of our Enterprise Select regions, and I've been working at Nutanix for about 3 years up to this point. One of the things we did in this region is we took on this kind of lunch and learn webinar series, and as part of that, we've already covered kind of core Nutanix, what's the full solution like. So that's our, what I'd call is our almost first call pitch, our first introduction to who Nutanix is. We covered a lot of different products and a lot of different things in that presentation. Mike Berthium did. Then we followed that up with really how do I manage, some of the analytics we have built into the management layer, and basically how do I just operationalize my Nutanix infrastructure or my Nutanix private cloud using Prism Pro. And then today what we're doing is we're going to start to get under the covers a little bit and look at some of the core products themselves. Acropois Hypervisor, or AHV as we'll call it, is really kind of just another way for us to simplify that infrastructure stack, much like we've done on the storage services with AOS. Really just allowing customers to leverage an embedded hypervisor to run virtual machines and really move up the stack and concentrate on working with their applications and virtual machines. And then in 2 weeks, we will actually have a flow seminar. That'll be done by Chris Gagan as well. So Chris, thanks for joining, and we'll look forward to hearing you in the flow seminar.
Thanks for the shout out.
All right, so today we're going to do, just because even though these are kind of building on each other, everybody that joins doesn't necessarily always know Nutanix's core story, so we'll spend a couple minutes on that. We'll talk about why we even have AHV, why did we think it was important to put that into our solution set, and then we'll spend probably about 35 minutes on actual walking through several different scenarios from an operations perspective. All right, so our charter really back in 2009, we had product in late 2011, was really around how do we take the things that our founders learned from big data, web scale environments like Google and Facebook, and how do we engineer a web scale solution that's designed for the enterprise. So these are the core tenets of that solution, right? So hardware is made to fail. So what we really wanted to do is come up with a distributed architecture. So we have a data fabric that spans all of the actual servers themselves, and everything that we do is software defined. So our networking, software defined networking that Chris will cover next week, our files product, our management layer, and our hypervisor and our storage services, it's all done from a software perspective. So it allows us to innovate very quickly, allows us to enhance it, as well as to secure it, come up with security patches, and be able to upgrade all those things non-disruptively and implement those features and those security patches without any downtime. So one-click operations is a core tenet of that as well. How do I just pay for what I know I need today? So a lot of times our requirements, we have maybe some day 0, day 1, day 2 requirements. The application teams themselves don't even know what they're going to need as they move into production, as they get through their staging environment. So what we allow you to do is leverage some of those cloud values in your own data center. So pay for what you need. You only need to start as small as 3 nodes from a cluster in your core data center. We have some robo solutions that are 1 and 2 node solutions, but really core data center product, we would start with 3 nodes. Rapid time to market, so you can, within about 2 hours, you can have your private cloud up and running, as long as we have network cables ahead of time and 3 IP addresses for each node. We can, in about 2 hours, get you a base private cloud configured, and you can start deploying virtual machines immediately. And I'll go through some of those virtual machine deployment, provisioning, network visualization, things like that today. One-click operations, again, how do I expand? How do I upgrade non-disruptively and be able to do that when I need to, or when I plan to on a much more frequent interval? We run into a lot of customers that are running very, very old versions of their storage OSs, or very, very old versions of even their VMware product, right? A lot of people still running 5.5 out there. So how do we continue to take advantage of that continuous innovation that a full software-defined product solution gives you? So this picture on the left-hand side, this is still what a lot of core enterprises look like today. There's some virtualization. We do have applications running at the top layer. There's a series of VMware hosts, so that's our compute layer. And then all of that storage is still connected over a fiber channel network for a lot of organizations. and there's LUNs that are carved up, and there's masking and mapping, and a lot of complexity in this solution over here. So I actually worked for a company before I started here 3 years ago, and our entire mission was to walk into large enterprises and show them where they had path misconfigurations, help them reduce risk by being able to validate that every single storage data store or storage LUN was configured and presented to the proper VMware clusters or the proper host that they had in their environment. So a lot of complexity here. That complexity means several different things. It means that I have to have a skill set for each one of these layers. I've got to not only have an application team now and somebody that understands the app side. I have to have someone that'll manage and monitor and provision the virtualization layer. So a lot of times that's not just the VMs and templating and deploying, but that's also the back-end management, again, upgrades for their virtual center, upgrading all of their VM environments. Then I have to have somebody that knows the storage. I got to have an SME with usually a hard-to-find skill set. And a lot of organizations find that turnover in their storage environment is one of the hardest things for them to recover from and really resource. There's a lot of different storage technologies out there. A lot of it still is very intricate, not quite as bad as networking from a command line and intimate knowledge perspective, but very, very complex also. So supporting that, a lot of times it's separate teams, so we get siloed support when we have a P1 issue. Everyone has to jump on a phone. We got 3 and 4 teams that are involved, and each one of them is really trying to go through their own domain. A lot of times we're trying to compare multiple screens, so we don't have the same time series. We have different end-to-end monitoring for each one of those as well. And then when it comes to capacity planning and sizing, I'm going to make a different exercise for each one of these. So generally, we're going to put a little overhead in. We're going to overcompensate for something that we don't know or we think could change down the road. And so we add extra capacity and extra resources in each one of these layers as well. So Nutanix's approach is really how do I consolidate that picture on the left into more of an appliance-driven architecture. So what we're seeing here is one of our standard high-dense 4-node 2U appliances. And so that means there's 4 ESX hosts or 4 AHV hosts in this 2U configuration. And that is enough to suffice as a single cluster. So I could run my private cloud on 2U in my data center, depending on how much capacity and CPU and memory that I need. It's very, very easy to expand. So in this case, we just expanded this up to 12 nodes. And we still have our virtualization layer on top. Typically, that was VMware up until about 3 or 4 years ago. In 90% of our environments, we do support Hyper-V as well. And over the last couple of years, we've seen our AHV implementations grow to about 40% of our environments. So we're just going to further collapse that infrastructure stack and that complexity into a full appliance infrastructure as a service stack. So I now have a private cloud in 246U with 12 servers, and each one of those servers can have up to 40 terabyte in that mode. So I could have 12 times 40 terabyte, a fairly significant private cloud there in 6U. And all of that is held together generally by a 10 gig backbone. So we recommend a leaf spine architecture generally just to keep as much of that cluster and node to node level traffic in that top of rack switch infrastructure. So what does it actually look like? This is a kind of a blown out view of what I just showed a minute ago. So here's our 3 ESX nodes or our 3 AHV nodes. So 3 servers running your virtualization stack. Each one of those servers has some sort of storage in them. So we have NVMe capable nodes at this point in time. We have all flash nodes, and we can run a combination of those of spinning disk and all flash or NVMe. And what that allows us to do is we take, you see there's a CVM for each one of these nodes. So this is really our storage, virtualized storage controller, or controller virtual machine as we call it. And so there's a VM running in the user space that has drivers to directly access the storage in each one of these servers. Those 3 CVMs in this case all talk together to build a single storage pool across those nodes. So basically we create a virtualized storage array by using the scale out distributed fabric in each one of those individual nodes. That has several different advantages. One is if I want to take advantage of things like 3D Crosspoint, NVMe, some of the modern technologies that are coming down, we have a core tenet called data locality. And so what that means is if I have 3 applications that are running on node 1, when they read and write I/O, I want that to happen locally. So we can service very, very fast, high-performance workloads as a result of that data locality. We can also heal very, very quickly. So if I have a particular drive or a particular node that goes down, I have the ability to self-heal across the entire cluster. So in that example previously where I had 12 nodes, I'm going to have 11 nodes and 11 controllers all working together to build that data set, or rebuild that data set, I should say. The other thing we can do is we can start small and then scale based on the appropriate needs. So we talked about that application earlier. They had test requirements. They knew what they needed to get started. And rather than go into some sort of shadow IT or Amazon, they were able to very quickly build a private cloud in their environment. And then over time, what they realized is that they actually had some more storage-heavy requirements. And so they were able to add 2 storage-only nodes. So we can take the capacity and augment that cluster with just capacity-based nodes. Or if we wanted to add more CPU, we could add a maybe core-heavy or higher gigahertz nodes to augment that and give more resources as required to that cluster. So very, very easy to mix and match node types and hardware generations as well. So expand that storage pool and add those storage nodes in. I literally just connect the additional 10 gig connections into the new server. Make sure that I have power, whether it's going in an existing chassis or it's a rack mount server that needs its own power. And then we'll go through a discovery process and be able to expand that very quickly. And I'll show that as well. So AHV, at this point in time, it's a fork of KVM. It was actually started about 5 years ago with a security project that we did through working with one of our very secure 3-letter agencies in the public sector. And they actually came to us. We supported KVM at the time, and they actually came to us and asked us if we could help them secure and lock down the KVM to run that hypervisor on our network or on our infrastructure. So that's really how AHV came about. We decided that it made sense to have a purpose-built hypervisor forked off of KVM that had all of the enterprise features that VMware had today around DRS and HA and performance tuning and things like that. Most people don't know this, but Amazon is currently running a combination actually of Zen Server and KVM in their data center. Google Cloud has had their own hypervisor that was also a fork of KVM for a long time. And even Azure has a lot of Linux tenants built into their Azure stack and their Azure clouds. So most people don't know at this point in time the hypervisor, what hypervisor they're running. It's really a commodity at this point in time is how do we service our business the best way. So if I have a lot of business logic already built into VMware and I'm using SRM and I use the vCloud Director and I have a lot of business process built around that hypervisor, then we're going to encourage you to stay with that, right? You put a lot of time, effort, energy. If it's not broke, don't fix it. But for a lot of customers, they are really just using their hypervisor layer as an end to a means, or a means to an end, I should say. And it's just there really to run more VMs on a particular piece of hardware, right? So it's there for density reasons. So why do people choose AHV? So, the hypervisor being embedded in the HCI stack, again, allows for a lot of simplicity and a lot of, speed to market or speed to value. So I don't have to maintain a separate environment. I don't have to have a separate management plane. Everything I do is through that same infrastructure stack and managed through Prism. We can expand it very easily as part of that compute platform, and we can upgrade it through that same mechanism. Features and fixes are available automatically, and we can use that one-click orchestration engine for our upgrades. And again, simplicity, eliminating silos. From a talent perspective, we no longer have to worry about someone knowing, 3 different people to manage this stack. The hypervisor just is basically embedded directly into that stack and allows us to manage that with the same resource. So this just kind of reiterates some of that same stuff, and that is why we went through the effort to have our own hypervisor. Why not just support KVM? Why not just support VMware? KVM is still cumbersome. It requires a lot of customization. If you've had any experience with OpenStack or any other KVM environments, you'll see that they're still missing a lot of enterprise features, and it's a lot of heavy lifting for people. The way it handles storage pools and compute and even software-defined networking really requires a high degree of complexity and domain knowledge. What we did was kind of took a lot of that core code base and really tried to follow along with what we've done on the storage layer, which is one-click management, give it simplicity, make sure that we have all the enterprise features that are required, make sure that we can manage it from a capacity planning perspective, understand where our headroom is and where we have our constraints and things like that. And then over time, what we've done is really started to build out our ecosystem. So making sure that all the major backup players support us, making sure that, antivirus and integration with a lot of the core enterprise stack tools that you guys use today. And so what we ended up with is distributed virtual switch infrastructure using Open vSwitch. So we have software-defined networking. We can do IP address management as part of that. We can do microsegmentation based on categories and make that very, very easy as well. We understand the storage plane as well. So because we own that full data set and the I/O path, we can make decisions as far as placement. We can look at hotspots. We can look at VM placement. We're going to truly take into account not just CPU and memory, but really the entire storage footprint as well. All right, so now we'll switch gears and move into some of the actual demos themselves. And it looks like I'm running a little bit behind here, so it might be a couple minutes, but let's get through these. So the first thing we're going to do is kind of look at how we would manage a multi-hypervisor environment, really show you how to deploy a VM on ESX as well as on AHV, just so you can kind of see the contrast and the fact that everything works the same no matter which hypervisor you're running. We're going to do a quick demo on things like upgrades, show you some network visibility and expansion. And then finally, if this was something interesting and you guys were looking at trying out AHV, how do I get my workloads from my ESX or my Hyper-V environment or even AWS directly to my Acropois Hypervisor cluster? And so we have a product called Move that allows us to migrate those workloads directly from your current state virtualization into your Nutanix cluster in a very, very simple to use process. All right, so let's take a look. All right, so this is our multi-cluster Prism Central. So Nutanix comes with you'll hear us use two different terminologies around Prism. So one is Prism Element, which we're going to show in a couple minutes here. And that's really the embedded management stack. So each one of those controller virtual machines I showed earlier runs Prism Element. That's our embedded management stack. It's a distributed management plane that allows you to configure and manage your cluster from day one without setting up any other management plane. Prism Central does it allows us, as you can see here, to manage many clusters using a single kind of manager of managers dashboard. So this is where we've moved a lot of the logic in our product. A lot of decisions and policies and workflow is actually going to come out of the Prism Central. This also is deployed in a single one-click process directly from the Prism Element dashboard. You can download and deploy a Prism Central. You give it 3 IP addresses. You tell it whether it's a small instance or a large instance. And within about 4 or 5 clicks, you have deployed a Prism Central dashboard. So in this case, you see here that we have for cluster quick access here in the middle, we have an AHV cluster, we have an ESXi cluster, and then we have a couple different hardware level clusters for our demonstration purposes as well back here at Nutanix. All right, so let's take a look here. I want to go into the VMs, and actually I see here we have a shortcut called clusters list. So we can see here a list of all the clusters that we have. Again, what versions we're running. So you can see they're all running the 5.10.6. We've upgraded them since they've been registered to Prism Central, so all of them show an upgrade status of succeeded. And then you can see the hypervisors, how many hosts are in each one of these clusters, and the number of virtual machines. And then cluster runway, some of the stuff Larry covered in the last webinar, but is really some of our machine learning where we understand how much capacity and headroom is left in your actual cluster from a storage, memory, and CPU perspective. So if I wanted to select the ESXi cluster here, you can see what actions are actually available to me. So I have the ability to go right here using Prism Central and upgrade the software version for each one of these clusters, no matter whether it's ESX or AHV. If I want to drill down into this ESXi cluster, here I can see now some more detailed view and summary data around the cluster itself. So today the health is in good shape. My capacity is about 15 terabytes. I've only used 180 gig. So I have lots and lots of cluster runway. I have plenty of resources here. I'm running only 10 virtual machines. My CPU and memory usage, I/O latency, all of the information that I'd want to kind of look at from a top-down view of my Nutanix cluster, whether it's compute or storage-related statistics in a single pane. Under virtual entities, we'll take a look at the number of virtual machines that are here. You can see here I have 10 virtual machines. So let's go ahead and create a virtual machine. I want to show you how easy it is. So you select which cluster you want to create it on. So again, Prism Central being the manager of managers allows you to select which actual environment you're going to deploy this to. And then we'll see here that it'll type up kind of a form-based deployment walkthrough. So it's all in one single pane. So let's give it a name. We will actually give it a guest operating system, very similar to you would do in VMware, so we can understand what drivers to use and things like that. I'm going to add a disk. I'm going to decide whether we want the disk to be on which container. So in this case, we'll choose the virtual machine container. So that's the placement of this virtual machine. And we're going to allocate this disk on the actual VM itself. Make it 40 gig. Scroll down here. We got our CD, we got our NIC. Let's go ahead and add a network adapter. I'm going to select the VLAN. So much like you do on VMware, you create all those port groups on the VMware side. Actually, all that stuff will flow directly into this particular screen. So we're going to use the demo network. And you can see I can even select which adapter type I want to use. Again, all this is coming from VMware. Do I want it to be connected when it powers on, disconnected? All right, let's go ahead and hit save, and it'll deploy this virtual machine. All right, so you see here we have a couple different virtual machines here. We're going to wait for this thing to finish deployment. So the CVMs are all showing up there. That's the machines with 32 gig. So that's our controller virtual machines. Again, they're just regular VMs in our environment. A couple test VMs. There's a cloned Nutanix VM as well. And we'll wait for that job to finish. There's the virtual center, if you see the VCSA there, and there's our new VM. We wanted to go through here. We can start deploying it. In this case, we'll go ahead and do a power on. We could update it, change any of the properties, delete it, clone it. In this case, we will just move on. All right, so now we're going to move to an AHV environment. So this is the Prism Central that has our AHV. It's our AnyRocks cluster here for the New England folks. We're going to show you the image server. So one of the coolest things we have in the Nutanix environment is really the ability to set up an image service. And so this is where we're going to store all of our virtual disks. So basically allows us for cloning and to use as a templated-based deployment mechanism. And we're also going to store all of our individual ISOs. So it really becomes a repository for all of your provisioning and cloning exercises. So pretty easy to set up. So in this case, we're going to go ahead and add a new image. We're going to copy the URL in. So for anything bigger than 4 gig, we usually use HTTP for the actual source. We'll give it an image name. I like to copy the full description down here so I can see all the kind of the 722.4901 version information, and then shorten my actual ISO name itself for the image name. Probably should leave the x86, x64, sorry. An ISO, so Windows 10 image. So we just here we can decide, we can leverage categories. So what categories are is it's our kind of business logic or metadata that we attach to the individual VMs, or in this case, the actual images itself. And it allows us to set policies. Okay, so based on the category or the classification we've given this particular asset, in this case, the image, whether it's a virtual machine or not, we'll show some examples later. This lets me decide if it's a certain category that says, Detroit, and I load it up here as an ISO or a virtual disk, then it's only going to replicate to the Detroit environment. So we set policies around that. This is helpful so you can have a single repository for all of your ISOs and all of your disks. But obviously, if you're running 5 different locations, you don't want everything to replicate into all 5 of those. So here, let's take a look at the actual VMs themselves. And we're going to go through the same process on how to create a virtual machine. In this case, we only have a single cluster, so it doesn't have us choose. So now we're going to create a virtual machine on AHV. And you're going to see it's the exact same process with one exception. So for here, let's give it a time zone. So we'll select the local time zone. And do 2 vCPU, 1 core per vCPU. For memory, let's give it 8 gig of memory. And you'll see here under CDs. So what we're going to do here is add our disk. Exact same process. We're going to give it a 40 gig disk. We're going to select the storage container that we want that disk to actually be allocated to. So in this case, scroll down. There you go, to the VMs repository. So now I have a hard disk for this virtual machine. And then I need to add an additional CD-ROM, because not only do I want to mount the CD-ROM for my Windows 7 that I just loaded, I also need to mount the CD-ROM for the VirtIO. So you see I'll click the mount from image service. And we're going to use the VirtIO driver. So since this hypervisor is a Linux-based hypervisor, we have to add the VirtIO drivers. This is common if you've dealt with KVM or any other Linux-based hypervisors. So now I have my VirtIO, so I can load my drivers during the installation, and then I'm also going to mount the Windows image that we just loaded here. So Win 10 Enterprise version 1511. All right, awesome. So we've got our 2 CD-ROMs loaded up for drivers. We got our disk created. We do support UEFI if you're using that internally. Let's select the virtual machine network that we want to use. Let's leave it connected. In this case, we could do IPAM, so if we wanted to give it a specific IP address, we could, but we actually have some DHCP pools set up. So our IP address management is already configured, so it'll automatically get a DHCP address. All right, so we've deployed this particular machine. It'll go through. You see it's been submitted. And let's wait for this thing to come up. All right, so there it is. So Windows 10 webinar. We'll go ahead and power this thing on. You see it's off. You can see the cluster that it's sitting on, but all the other properties are there. Awesome. So successfully submitted the power on. We'll wait for the power status. Let's go ahead and launch a console. So this is very similar to VMware's, console. It uses a VNC viewer behind the scenes. And this is where we can do a console session and start the actual configuration. So I sped this up a little bit just because we're trying to cover a couple things. But you see there's where we'd actually select the driver so we could identify or see the disk. Very easy. We just browsed that VirtIO driver and selected the x64 directory under Windows 10. All right. Okay. So there it goes. We're starting the machine. I'm going to go in there and actually eject that CD-ROM. Oh, it's a little big in the boots. We're going to update, and we'll actually just select to eject that CD-ROM from the device. Go through and finish the installation. And you see here, this is where we'll go through, and you see a couple unidentified device drivers. There's for the Ethernet controller, so we don't have network connectivity yet. If you look on the bottom right-hand side, the same thing. We'll go through and browse that VirtIO. We only ejected the Windows driver here. Under Win 10, go to the AMD 64 directory. And voila, now we have networking. Do the same thing for the video drivers and the VirtIO. Much like VMware tools, we also have our own tools that we can load up on this machine as well. So there we go. So we had some network connectivity. So that was a successful deployment there. Now we're going to go through and we're going to do some of the higher level things. So I want to go under categories. And under categories, you can see here, there's a list of all the system-based categories. So these are all of the default categories that show up. So we have application family, application tier, environment, app type. This is where we can see, we can go through and configure our own. So for this particular instance, I want to create an application tier that's called desktops, because this is just a Windows 10 desktop for one of my developers. We'll go through here, and under the application tier, we'll add an additional value called desktops. All right, awesome. So now let's go back to the VM. Let's assign it to the desktop category. So back to virtual machines. Now we could start this virtual machine and kind of give it a shortcut and have it show up in our help menu up there as a shortcut, our favorite. So let's go ahead, it's selected. We're going to manage categories. We can now free text search. So if I type desktops, you see I don't have to do it in caps. It will show up. So we've assigned it. If I wanted to add an additional, maybe I also wanted to add something like, test for an environment, I could do that as well. We're not going to in this case. All right, awesome. So now that we've assigned it some business logic, now we can actually go to policies. So in this case, we want to look at one of the security policies that we've created. These are flow policies. Again, Chris is going to go in these in much more detail. In this case, we already had one created that was called desktop isolation. So if you see this, this really says, hey, I want to take these two categories and make sure that they don't talk to each other. So anything that I tag with the desktops category cannot talk to anything tagged with the production category, okay? And so in this case, you can see that there are a couple different ways we can do this. So if you look at the top, this says it's the top left, it says it's monitoring. So this is the status of monitoring. If we wanted to go through and apply this, we would actually block the traffic, but right now we're just going to view the traffic. So we'll show those as unrecognized or unapproved flows, actually. So let's go through and make sure that connectivity is working between those. So we'll go back to categories, and let's find a machine that's actually tagged with the, we know our desktop is tagged with desktops. Now we've got to find one that's tagged with production. We have 2 virtual machines today that are categorized as production. So I want to use this web server that's 10.42.160.99 that was actually used in our move migration that we'll see here in a minute. So let's just verify I'm in the Windows 10 webinar console still. I just want to have my networking now. We tested our virtual, our website traffic, but let's make sure that we have traffic to ping this machine. So we did. So that traffic is not being blocked today. If I want to go into this desktop isolation policy and change it to say apply, so don't just show me the flows that are not approved, actually block them. So this is a hard isolation at this point. So what we do is see a lot of customers want to do this if they have a bunch of third-party developers. They don't want them to be able to get to their PCI domain. They don't want to be able to get to certain VLANs or certain applications. This is a great way to do that from a category perspective. And so you just tag it as you do the provisioning. All right, awesome. So we have indeed blocked that traffic. We are no longer able to ping. Beautiful. All right. So one of the other really cool things that we have in our product is, actually we're going to go through here and just verify, sorry, with another machine called Tools that's not tagged as environment production. So this is one of the non-production machines. I just want to verify that we can actually ping this machine as well. So let's go ahead and see if we can ping 98. All right, awesome. So we do have traffic. We're not blocking everything. We're only blocking to that particular category, the production category. All right, so now let's go through some of the CLI stuff that we have in our product. So we have ACLI. It's a very intuitive, easy to use batch level CLI. It's really designed around being able to do large scale, clones, power on, power off, any kind of administration that you'd want to typically script or do in a batch scenario. So this case, we'll look at one of the CVM IP addresses. This is .31. We'll SSH into .31. So in order to access the CLI, you just SSH into any of the controller virtual machines. Let's go to ACLI. That puts us into the command line. So we'll do a VM.list, look at all the virtual machines. You can see here, there's our Windows 2016 machine. There's our Windows 10 clients. There's our webinar. Let's go ahead and sort by webinar. You can see what machines are currently listed there. So Windows 10-webinar is the only one that's there today. Back to our SSH, start some clone operations. So in this case, we're going to do VM.clone. I'm going to clone the Windows 10 webinar machine. I got to give it a name for the actual target, or the actual target destination VMs. So we're going to call them webinar 01. We're going to do 5 of them, so webinar 05 up to 05. And we are going to clone from this Windows 10 webinar. You see you can use free text for this as well. So Windows 10 webinar. All right, awesome. So I now have just cloned 1, 2, 3, 4, 5 new machines. And you see there that filter immediately changed to webinar 1, 2, 3, 4, 5. So let's just actually change this view. So now we can just look at the Windows webinar machines. Now we're going to go through and power them all on. So I have 5 new Windows machines that are all tied to the source image. So I'm just going to concatenate, literally type the names that I want to turn on. So you see how easy to use the CLI? Very intuitive. All right, so 4 and 05. So we'll turn these things on. Enter. So again, the CLI is really designed for batch level operations. You see here they've all been turned on. Looks like they all got placed on host 2 and host 3. Go ahead and just turn them off. So let's do a shutdown, and then we're going to actually remove them. Just wanted to show you guys a quick example of some of the things you can do with AHV and the ACLI. All right, so we got 2 more to go. All right, so as soon as these are all shut down, there we go. So loading, there we go. So they're all shut down. So we'll just go ahead and delete those operations now. In this case, since it's a delete, it wants to ask you to confirm. And you'll see here in a second, they are all removed. Just kind of an end-to-end life cycle. If I had an operation where I wanted to go clone a bunch of desktops for a test, this is a very, very simple way to do it. I did it in about 5 minutes. All right, so now let's jump into kind of some of the settings. So this is where we'll look at how to upgrade the software. So we'll go through a quick upgrade. In this case, we're going to upgrade AOS. You can see here, we could, through this mechanism in Prism Central, we can actually do an orchestrated non-disruptive update of our storage software, of the file software, if we were running our Nutanix NAS product, and of the hypervisor. At this point in time, it says no available versions to upgrade. That's actually because it's embedded in the hypervisor, the AOS version. So if you're running the latest version already, there's no versions to go to. So we're going to go through an AOS upgrade first. So we'll run the pre-upgrade tasks here. So this goes through, make sure all the prereqs are in place, everything's healthy. It'll run the NCC checks in the background, make sure there's no issues with this before we go through the upgrade. So in this case, you see we made it through all the pre-upgrade steps, so no issues. So we go back to versions and we say, yep, let's go ahead and do the upgrade now. So this will go through and non-disruptively upgrade in a rolling fashion. So it's cluster aware. And what it does for the storage software literally is that it'll upgrade one CVM. It'll redirect all of the I/O traffic for one CVM on one node. Once it's done with that upgrade, it actually moves on, powers it back on, inserts the route so everything goes back to that particular storage that CVM, and then it moves on to the next host and does the same thing. And so it'll go through the entire cluster without creating any sort of downtime for your virtual machines or hosts themselves when you're doing an AOS upgrade. So it's pretty slick stuff. It actually, usually we don't even drop a ping when we're doing an upgrade and we're seeing a machine because it is a proactive change from a store traffic perspective. All right, so you see we are upgrading CVM 10.38.12.198 in this case. And we've sped this up too, just to kind of make this be able to cover more ground here in this particular hour. So this is the console that's used to manage and upgrade your entire cluster, regardless of what the hypervisor is or what the version. So it's disconnecting. In this case, it's the same host that we were on from a management perspective. So you'll actually see it disconnect, give you a message, and come back. Sometimes you have to relog in. Usually you don't even have to relog in, though. 98% from this AOS upgrade. All right, awesome. So the UI has been upgraded, and now we'll move on to the hypervisor. So you see there was a current version, there was another version. Sorry, it went kind of fast. To select. So now that we upgrade AOS, there was a new hypervisor package there that we could use. We did the pre-upgrade. Now we'll go through the upgrade process for this. So notice we haven't left this screen. To go to 3 other consoles, we've managed our storage layer and our hypervisor all from the same Prism Central instance. And for the hypervisor upgrades, it's the same process, but it does actually, it's cluster aware. It will do a rolling upgrade. The only difference is it actually vMotions first, similar to what you'd expect in a VMware upgrade. And we do the exact same thing if you're running VMware from a hypervisor perspective. So in this case, what we do is really migrate all the VMs off to another node, upgrade that particular host, bring it back online, and migrate the VMs back. Hypervisor upgrades happen, again, cluster aware, non-disruptively, but they do a machine move. So in this case, I just wanted to give you an idea for how long this particular upgrade took. And so the real time was about 20 minutes to go through this particular upgrade. So this is the hypervisor itself. Same type of thing, you notice. A series of disconnects that the management layer itself is unavailable while it's going through that upgrade, because we're on the same node. Beautiful. All right, so successfully upgraded the hypervisor here. So the next thing we want to do is kind of drop into an environment and just walk you through how you'd expand. So similar to the upgrade itself, you go into the settings, go to the cluster settings. This is a 4-node right now, 3060. If I want to go to expand cluster, this is where I go through here and it would populate. It's the first thing it's going to do. So if we had plugged the machine in and it was sitting here, and it just was on the same network top of rack switches plugged in, and we were allowing the IPv6 broadcasting, it would immediately discover that there was an available node to pull in to expand this cluster. So in this case, we didn't have any nodes available, so we could actually go through and manually update it. So we could put an IP address on using some sort of IP management or ILO type out-of-band, give it an IP address, and literally discover it manually as well, all part of this foundation or this cluster expand exercise. So you do the cluster expands here as well. Here we can view in this switch layer, we can view the actual physical switches themselves, so we can pull them in via SNMP. We can configure VLAN similar to how they get pulled in with port groups on the ESX side. You can see you can do all of your virtual network and physical interfaces as well. And here, if we go into the actual network diagram, this is where we're going to be able to look at all the VMs that are on this particular cluster. So now we've gone into a Prism element instance. So this is that embedded management layer. So in this case, you can see here that I have a virtual machine called DevOps Flow Client. It's actually sitting or being hosted on demo AHV3. And I can see in this case, both of the connections, I've got 2 outbound connections, but unfortunately, they're both configured to go to the same switch. And so ideally, I would have this VLAN being supported off 2 different switches. So you can see that in this case, that uplink port is going to a single switch. So you can look for misconfigurations here. You can look at what VLANs are configured. You can look at the actual topology as well. All right, so the last thing we want to do is cover, and again, I know I'm throwing a bunch at you guys, but is really how we move from an ESX or Hyper-V or even Amazon environment and migrate my virtual machine seamlessly to an AHV environment. So in this case, I'm just going to go through and show you. We have a VM here, series of Windows 2016 VMs, but we have a web server. That web server today is 10.42.87.52. I just want to see if there's any kind of name resolution for that particular VM. So we'll do a ping -A and get the name itself. So I can see here that it's webtest.nutanix.dc.local. So there's my web page, watch me move. Just a simple web page example here. Now, if I want to jump into the actual move utility, so it's just a virtual appliance that you import into your environment. This particular move appliance is using 10.42.160.56. Let's go ahead and log into that management layer. All right, so log in with your credentials. And the first thing you'll do is see a wizard or some screens that kind of lead you to add your source and your target environment. So our source environment is going to be the ESX environment in this case. We'll select our ESX, give it a friendly name. In this case, we're going to use PCO87. ESX move, we'll give it the IP address of the virtual center itself. We need the credentials for virtual center. So this works actually whether it's a Nutanix environment VMware to migrate into AHV, or if this is a standalone sitting on some HP servers in an EMC array, right? All we do is talk to Virtual Center. We can build that replication traffic from a non-Nutanix storage layer running VMware back to a Nutanix AHV environment. So very, very cool stuff. So in this case, we have 9 VMs. None of them have been migrated. We'll set up now our destination or our target environment. So this is going to be our AHV environment. PC 160 AHV. We will point to either our Prism or our Prism element IPs. In this case, we're going to use Prism Central, which is 140, as you see. And this is where we want the Prism credentials. Prism can be LDAP. For this lab, we don't have LDAP integration, but clearly your credentials could be LDAP on both sides here. All right, beautiful. Now let's set a migration plan. So we have our source environment, we have our target environment. Now we're going to create a migration plan. Give this migration plan a name. Let's migrate 087. We're going to select what cluster we want it to go to. So our target cluster and our target container, where do you want those VMs to be placed? Similar to when we did provisioning earlier. So in this case, we don't want to move the Virtual Center adapter. We're not going to move Prism Central. We are going to move our 3 2016 virtual machines. So our SQL Server, our Tool Server, and our Web1 server. So there are no warnings. So we're in good shape there. It'll do some prerequisite checks here. Let's check next. Make sure we have enough headroom. In this case, we're going to do automatic preparation mode. This is where you can set some, prerequisite tasks in there, power things off, change things. We'll give it credentials because it needs to go in and update some drivers as part of this process. So we're going to give it the credentials to the actual Windows machine itself. We could have told it just move them over and don't log into them, and that's where that manual and custom comes in the preparation mode. In this case, we're going to give it credentials and tell it to do what it needs to do. We're going to automate as much of this as possible. We could also leverage a PEM file for authentication on the Linux servers. So if we had some sort of license reasons that we had to maintain our MAC address, or if we wanted to just move the data, let's say there was D&E drives, but we don't want it to bring over the Windows operating system for some reason, maybe it's a version change, things like that, we could select those. In this case, we're just going to bring the whole virtual machines over. Validating passwords, it'll go through and make sure it can log in with those credentials. You'll select the source and a target network. So we're going to move this to network 1, which we know we have DHCP and available IP addresses on. Now we could schedule the data seeding. So if we knew we wanted to cut over on the weekend, we could actually say, hey, do the seeding, tomorrow night, in the middle of the night. And then when I come in the morning, or I'm going to cut this thing over. In this case, we're just going to do it all at once in the interest of time. All right, beautiful. So we kicked off the migration. So now it's validating the plan. In progress. So what we're going to start to see is that it's going to go through prepping the original machines. One of the prerequisites it does is make sure it has proper drivers in order to bring it from that VMware into this environment. So I have to make sure that I already had my Nutanix guest tools, which put the Virto.io drivers on the OS itself. So now what it's doing is it's going to go through and actually prep those, snapshot the machines on the source side, and start replicating that data over in preparation of a cutover. So if we click on in progress, we can see it's a little bit more detailed. So there you go. It's installing those device drivers, preparing the source VM. In this case, we're going to keep the MAC addresses. Mount the new container in order to start replicating that snapshot to. You can see the two bottom ones don't have as much data. They're not the SQL server, so it's a little bit behind. Create our initial, start moving and syncing those snapshots. You can see that's the seeding data. So if we had scheduled seeding data, this is all the stuff it would have done ahead of time. Migrating all this data, you see it'll take up to 30 minutes. Again, I have this set up a little bit, so it won't take quite that long for us. So as soon as it creates that snapshot and starts syncing it, starts to define how much data it thinks it's going to end up having to migrate. And then you'll see it come up with how long it's going to take. So it's going through the tools. It's actually going through the data migration itself. So we have almost a gig in the tools directory. And so you see it just going through that migration at this point. So this could be one facility to another. Like I said, we support Amazon migrations. That was a release we had about 6 months ago. So if you've migrated and you're running some, you found some shadow IT that people have put out there and you really want to bring those back, but you don't want to have to undo the operations that have been done, you can literally point this to your Amazon instance. It'll do the exact same thing where it logs in, creates a snapshot, replicates that back. Pretty slick stuff. And then the Hyper-V one, actually, we released fairly recently as well, and I've heard that one works seamlessly. So there you go. So not huge data sets here. A lot of this is local, but it took about 30 minutes to migrate this in real time. You see the SQL Server was a little bit bigger data set. So here we're going to select the VMs themselves, do the cutover, shut the VM. It's going to disconnect the NIC. It's going to power everything on the other side. We'll look over here to back to the original Prism instance. There's our 3 VMs still. If that web server is still alive, just to get a feel for where we are in the process. All right, so let's see here. These should be turning off any minute. There you go. So they're all turned off at this point. Go over to move. We can see final data syncing, creating those last snapshots and syncing. Make sure we have all of the data committed over into the new environment, and now it's going to power them all on. Fantastic. So here we can see what the IP address is. This is 99. I'm moving kind of fast, but 10.42.160.99 in the new environment. Beautiful. So watch me move now in my new cluster on my new VLAN in POC 160. Let's go ahead and update the DNS record. In this case, it's a lab, so we're just using a host file. And we'll verify that we have connectivity over the new name. Awesome. Then we'll just verify that web page one more time. And that's how easy it is to migrate your environment over to AHV. Helps if you have permissions to the file or have it in write mode. All right, beautiful. So let's go ahead and open a new browser. And let's type in web test local. Excellent. All right, awesome. So this is now fully migrated. We'll just jump in real quick to log into the virtual center instance and just make sure those machines are down. So in this case, I want to, there's my NE-ROX cluster. I have additional VMs now. Look at the list of virtual machines. I should have my new VMs. Let's filter by that webinar, Windows 2016. And now you can see I have 3 new machines that have been migrated over and all are powered on. So that's the 3 that have a host name. There we go, sorting that here. So there's my tools, my SQL, and my web servers. And they're all on Hyper-V Hypervisor at this point. There's my new IPs. So plan has been completed. You can save that off. And then as a final check, I always like to log into the original virtual center, just make sure those machines are showing up as powered off. So we'll log into virtual center. But you can, and you know, even if you're running a Nutanix environment on VMware, you still use virtual center. We don't do anything where we take control or don't allow you to do operations inside virtual center, other than things like maintenance mode and things that would turn off that aren't aware of the CVMs. All right, excellent. So they're all powered off. Beautiful. All right. So right at 1 o'clock, I'll just finish quickly saying, you know, lots and lots of public references. About 40% of our nodes at this point in time are AHV. Essentially, any workload that you might want to run on there, I'm sure we can find a public reference for you or find a reference for you at the very least, so you can have a call and get some comfort with that. But the ecosystems continue to grow, and at this point in time, you know, we've been out for about 3 years with, you know, supporting customers and helping them. And it's not just on our side, you know, obviously we do some self-validation for certain vendors, right? But here's a list of the vendors. You know, you see Commvault's announcement on their website, Juniper, Veeam, you know, all of these vendors themselves have gone through and co-engineered and validated AHV support as well. So the ecosystem is continuing to grow, and it will continue to grow as we get more and more support. And AHV was actually the first hyperconverged platform to be certified by SAP HANA to run HANA, by SAP to run HANA. And so at this point in time, we don't require any sort of under the covers modifications to make it work. You know, I think some of the hypervisors originally were telling you to turn off checksums and things like that in order to get the performance and the validation. In our case, it's literally just native AHV, and SAP has gone through and done their own certification, so we show up on their website. Well, thank you very much. I think we are right at the 1 o'clock time hour. And again, in 2 weeks, we'll have a Flow deep dive by Chris Kagan. And have a great day.